Hello everybody. Welcome back. Today we will learn about the Thevenin theorem. This is another way to rearrange a circuit. Thevenin's theorem states that a two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistor RTH. Looking at any original circuit, you can modify it to look this circuit by using the theorem. After picking a load resistor, the rest of the circuit at the terminals of the load resistor can be reduced to just a voltage source and a resistor. At the end, the load resistor, the Thevenin voltage and the Thevenin resistor are connected in series to form the circuit. There are two cases when it comes to find the Thevenin resistance. Case 1, the circuit has no dependent sources, only independent sources. To find RTH, we should turn off all the independent sources, and find the input resistance between the two terminals. To turn off the voltage source, it is shorted, while to turn off the current source, it is opened. The input resistance is the equivalent resistance from terminal A to terminal B of the load resistor. Case 2, the circuit has dependent sources and independent sources. To find RTH, we should first turn off all the independent sources. The dependent sources are left on. A voltage or current source of a certain value is placed at the current terminal. It is usually a 1-volt voltage source that is applied at the terminal. Find the current that passes through the voltage, or if you choose to apply a current source, find the voltage across the current source. Finally, use Ohm's law to find the resistance. That resistance will be RTH. To note, sometimes with dependent sources you will find RTH to be negative. This means that the circuit is supplying power. It is possible with dependent sources. Now to find the Thevenin voltage. When the load resistor is taken out, what is left are open circuit terminals. The voltage at that terminal is the Thevenin voltage, also known as the open circuit voltage. In this example, we will find the Thevenin equivalent of the circuit to the left of the terminal AB and find the current through load resistor R4 when it is 36 ohms. First we will remove the load resistor so we can work on the rest of the circuit. The rest of the circuit is what we will use to find RTH and VTH. To find RTH, the independent source are shut off and the equivalence resistance from terminal A to B is found. First, from the perspective of terminal A and B, we see that R1 and R3 are in parallel. The equivalent resistance of that is now in series with R2. After calculations, RTH is found to be 4 ohms. Now to find VTH. VTH is the open circuit voltage at terminal A and B. Remember, since it is an open circuit, the other elements in series with the origin of the open circuit are removed. So R6 is removed. This is what is left of the circuit. Now to find VTH. We will use node voltage analysis. After the analysis, VTH turns out to be 30 volts. Now with RTH and VTH, we can construct a Thevenin equivalent circuit with the resistor load R4. Now to find the current through resistor 4 with Ohm's law. The Thevenin voltage divided by the series combination of resistor 4 and the Thevenin resistance gives the current through resistor 4. The current is 0.75 amps. With that done, let's look at an example with dependent sources. In this example, we should find the Thevenin equivalent of the circuit. To find RTH, turn off the independent sources. But since they are none, let's move on. The dependent sources are left on. A 1-volt voltage source is applied at terminal AB. Now to find the current that flows through the voltage source. Let's not forget, there is a dependent source with the variable of Vx. Vx, as seen in the circuit, is the negative voltage of resistor 2. We will use mesh analysis to find it. After doing the analysis, we are left with two equations for each mesh. Solving these two equations yields the mesh currents. Using I2 we can find the current I0 of the applied voltage source V0. We can find our TH using Ohm's law. Using the applied voltage and the current through it, we found our TH to be 7.52 ohms. Now to find VTH, which is the open circuit voltage at the open terminal. After adjusting the circuit, we are left with a single loop circuit with VTH in this case as the voltage of resistor 3. Mesh analysis shows the mesh current to be 0. So VTH is also 0. Now that marks the end of the example. Thank you all for listening. This theorem is just another way of analysis. Doing normal analysis can still help you find the current or voltage of any element. But it is important to know in case you are asked. Practice other questions and have fun. Till next time.